Okay, so next here, TEST-2F continuation video 11. Okay, so remaining part of the portion for this test, we're going to do tuition note question 5, continuing from the previous video. We've done up to B, so let us go to C. Writing the word equation and then skeletal equation and then balancing it. So dilute sulfuric acid reacts with aluminum powder. So let us do that. Dilute sulfuric acid reacts with aluminum powder. Okay, let's write the word equation. Dilute sulfuric acid reacts means plus aluminum powder means we can simply write it as aluminum, give you. Now let us write the skeletal equation partially, then we'll get the idea what will be there on the right side. You don't need to memorize this because these are all very easy to figure from the left side because there are displacement reactions. Okay, so here dilute sulfuric acid, we know formula is H2SO4 AQ. So react plus aluminum, we know is Al, the atom. Aluminum ion is 3+, but this is aluminum means the atom. Okay, go to page 47 of your textbook, then you will find that the aluminum metal is definitely above hydrogen, which means it's more reactive than hydrogen. In other words, it can replace this hydrogen and make it come out here as hydrogen gas. So this is hydrogen ion, this is hydrogen atom, this is hydrogen or hydrogen gas. Hydrogen means hydrogen gas. Okay, so next here, so we write here, we got it, so we can write the word equation hydrogen plus. So word equation means writing the equation with plus signs on the left side, arrow, and then on the right side, but no symbol, the English words. That's called word equation. So we can easily figure out here, if Al replaces this H2, then aluminum and sulfate. Definitely this will be aluminum sulfate, because SO4 2- is sulfate. So we look at that and remember our starter and do. So aluminum ion is Al3+ here, so 3+ there, and sulfate SO4 2-. So the valency here 2, here 3 cannot cancel, so this 2 at the top of SO4 will go to the lower backside of Al, and no need to put bracket because aluminum signifies one atom only, aluminum atom. So that's a simple ion. So in cases of simple ions, we don't put bracket. But when you're bringing down this 3 at the top of Al to the lower backside of SO4, we need to do so by putting a bracket first, because SO4 2- sulfate ion is a compound ion. Why? Because it has more than one atom. You see, one sulfur atom and 4 oxygen atoms, so together 5. Any ion having more than one atom is a compound ion. So, and if it's a compound ion and the valency you're bringing down is 1, then no need to put bracket. But if the valency is greater than 1, like in this case 3, then if it's a compound ion, we need to put bracket, then only bring down, otherwise it is wrong, right? So now this is the skeletal equation. Now we need to balance it. So you can make the table like you do with your pen, atoms. What atoms are there on the left hand side and the right hand side. How many atoms are there? Let us see. First atom, H here, 2, no H, here 2. So hydrogen 2 left side, right side also 2. So far balanced, right? Then next S. At the back of S, no number means one sulfur atom. Now this 2 is the subscript of H, so it cannot belong to S. So S is only 1. So sulfur left side 1. Right side is, now here bracket means this 3 at the back can belong to the front when it's a bracket. So this 3 is common to S and O4 here. So 3, no number here 1, so 3 ones are 3. Of course, this 2 belongs to L, doesn't get involved here. But this one is, because of the bracket belongs, the meaning of the bracket is belongs to everything inside. 3 ones are 3s, so right side is 3. So it's not balanced, right? So balanced equation here. Here, see, okay, we have written the question in the previous video, sorry. So balance means it should be equal. So in order to make this 3, as we've been saying, we cannot put 3 at the back. That's not allowed in balancing. Right to the front we have to put, and this 3 should be slightly bigger than the back subscript 4 and 2, okay? So here 3 now, no number here 1, so 3 ones are 3s. So now write these things in the boxes with your pencil. Left side 3, right side also now 3. But that has disturbed the hydrogen, so 3 2s are 6. So that's why we're saying right with your pencil, because you need to erase it out, right, and readjust again. So 3 2s are 6. So here we need to put 3 slightly bigger than this 2. 3 2s are 6. Then both sides are equal now. H is done, hydrogen atom, sulfur atom, then oxygen now. So oxygen here 4 on the left side, and right side is 4 3s are 12O. So that cannot be. So in order to, oh sorry, this also 12, sorry. Here now 3 belongs to everything after that, right? So 3 4s are 12. Left side also 12 oxygen atoms. Right side also 12 oxygen atoms. So balanced. Now O done. Then Al is the final one. So one more atom. So here Al, left side is 1. Right side is 2. So that cannot be. So we have to make this one also 2 by putting 2 in front. Now left side 2 aluminum atoms. Right side also 2 aluminum atoms. So all the atoms that are there on the left side, means the reactant sides of the equation, are equal to the number of atoms on the right side, that is the product side of the reaction, sorry. So this is how we balance chemical equation. So whatever atoms are there on the left is found on the right. Nothing is lost. And no new atom also formed. This is called law of conservation of energy. In other words, law of principle of atom conservation. That means what atoms have reacted on the left side has to appear on the right side in equal numbers, and no new atoms will appear. No, all atoms that were there on the reactant side should get lost once the product is formed. That's called principle of atom conservation. Okay, C. Then let us go to D. One more chemical equation. D. So let us see what is this. Dilute hydrochloric acid reacts with iron filings. So let us write it down. Dilute hydrochloric acid reacts with iron filings. So iron filings means the iron nail you take and cut with iron cutter, you'll get some iron powder, right? That's called the iron filing. Okay, let's write the word equation. Dilute hydrochloric acid here, reacts means plus, with iron filing means we can just write iron. What will be formed? Let us see by writing the partial skeletal equation. HCl hydrochloric acid plus iron, we know the symbol is Fe, which is a solid if you want to mention. Now go ahead and see page 47 of your textbook again. You will see the reactivity series of metals, and you will see definitely iron is above hydrogen. So you can easily replace this hydrogen and cause it to come out as hydrogen gas. So this is the hydrogen or hydrogen gas. And then, okay, so here, now it's not difficult to figure out what will be the next. Once Fe take the place of H and combine with Cl, that is Fe iron and chloride, iron chloride or ferrous chloride. So this will be ferrous chloride. Or you can also use, as you remember in starter, iron to chloride. It's the same substance. Any of these two, you need not write both, okay? Now ferrous is Fe2 plus, chloride is Cl1 minus. So the valency here 1 and here 2, so 2 will go to the lower backside of Cl. So that is the formula. Our next job is to balance. So you make another box like this for this equation with your pen. Okay, just do it slowly, no need of scale, I think. First atom here, H, 1 on the left side, right side 2. Cannot be, so to make it equal, you write here 2 in front. Now this has become 2. So we write inside the boxes with pencil so we can adjust and write. Because we're doing by trial and error, right? 2 Cl, right side also Cl2, so Cl, chlorine atom, 2 on the left, 2 on the right. Next is iron, Fe. Left side 1, right side also 1. No more atoms, only these 3 atoms. Equal numbers, left and right are all equal, each of these atoms. So the equation is balanced now, right? So final question, that is 11, okay? Pause the video and write it down and then come and replay it again if you need to. But it's important to write it down. Those who have the tuition note, you would be writing with your pencil on tuition note directly. There is space there. Okay, so here now. This question, acids do not show acidic behavior in the absence of water, but do so only in water. They show acid behavior only in the presence of water. Justify this statement with the help of chemical equation. Okay. Before you go to chemical equation, we remember hydrogen chloride gas that comes out is not able to turn blue litmus to red. All acids should turn blue to red litmus. In the beginning of the video we did it. But then HCl has the potential to be an acid, but why is it not able to change the blue to red litmus? Because it has not yet been dissolved in water. In other words, the H plus will come out only when you dissolve in water. So when you put this one HCl in the water means AQ, then this is released. H plus is released only when dissolved in water. And this is the one that turns blue to red litmus. So the dry hydrogen chloride gas could not do it because it cannot release H plus ion because of its dry nature. No water is there. But once the same thing which could not release H plus is put in water, immediately it releases, and the liquid dissolved, hydrogen chloride dissolved in water is able to turn blue to red litmus because the hydrogen ion has been released. So that's acid do not show acidic behavior in the absence of water here, but do so in water because of this. Now justify with a chemical equation. So here H plus, this one, hydrogen ion will show the acidic behavior only when it dissolves in water, because only then the hydronium ion is formed. Write along with me, hydronium ion. You see, H plus 2, H3O and plus. H3O is always an ion plus, okay? And this is the one that turns blue to red litmus. So unless there is water, the H plus cannot turn to this, which is the acidic behavior to turn blue to red litmus. That is why the acids do not show acidic behavior in the absence of water. I hope you got it. This is the equation that the question is asking. This is a textbook question on page 36 also. Okay, so this concludes the video. Now you go and write the test 2F. Okay.